All right, so we're going to start off with acid-base identifying. What? Oh, it's the record button. Yeah, no, feel free to ask questions.
Always asking stupid.
So with identifying acids and bases, this is just a small portion of your quiz. Basically, I give you a formula, and whether you say, oh, it's an acid, or it's a base, or it's a salt, which is neither one of those things. All right, so we have an acid. How do you tell if a compound is an acid?
Hydrogen.
It has hydrogen where?
In the front.
In the front. H in front. So whenever you see HCl, it's an acid. HBr, it's an acid. HClO3, it's an acid. Any H in front, it's an acid. How about a base? How do you know if a compound is a base?
Oxygen.
Just oxygen?
Gosh, you just made yourself look stupid. OH.
OH.
Yeah.
So the hydroxide, OH, is that in the front or at the end? At the end. What? HOH is water. And is water an acid or a base? Huh? So actually, fun fact with water, water can be both acid and a base depending on what it reacts with. Yeah. Charlton, stop. Alright, so how do you know if something is a salt? Is when you have a metal and a non-metal. So basically, if you don't have neither of these things, it is considered a salt. So we know sodium chloride is a salt. Potassium bromide, potassium chloride, anything that doesn't have H or OH, it is considered a salt. So for example, hint, hint, wink, wink, nudge, nudge. NaOH. Acid, base, or salt?
Acid base.
Base. Because of the OH at the end. Good. How about, bless you, HBr? Acid. So this is basically what you'll be expected to see, like HBr, blank, and you write acid or base.
So if it has none of those, it's just a salt.
Exactly. So if I give you like aluminum chloride,
Salt.
that is a salt. Pretty straightforward.
Is it gonna be like none?
Huh? No. It's going to be one of those three. I'm trying to close the pen, but my hand's a little swollen today. Yesterday was fine, but today, woke up a little swollen. All right, acid. How are we feeling on identifying? Pretty easy. Now, naming. This is where a lot of you struggle with this a little bit. The good thing is, tomorrow's quiz, the naming is only worth 1 point of your entire quiz. Okay? So, but if you miss it, you get a 9 out of 10. Did I say tomorrow? I meant Monday. Yeah, my bad. No, we don't have school tomorrow. No.
That was my only pencil. I missed.
Alright, so I'm going to start off with bases. Okay? So bases, we already established that they have the OH, so that's hydroxide. Do not name it as oxyhydrogen or something like that. It is called hydroxide. So how you name bases is you name your metal, whether it's calcium, sodium, potassium, barium, whatever, and then you name hydroxide. Name itself. What's going on?
I lost my eraser.
So we're dropping things in the camera.
You're a dog. You're a rage baiter.
All right, for example, so on your quiz, you'll be given like the formula. You write the name, and then the other way around. You have the name, you have to write the formula. So writing the name is easy for bases because CaOH2. What's the name for Ca?
Calcium hydroxide.
Calcium, and then hydroxide. That's it. Now, if I give you a name, lithium hydroxide, you write the symbols. So you write the symbols, and then what's the very last step you have to double check on? Balance what? The what? Subscripts, so charges, yes. So we have lithium, which is Li, and hydroxide is OH. Do not put HO. At least one of you will do that. Don't be one of them. Okay?
I will do that.
I'll probably see one person put LIHO. That'll be wrong. Okay? So, and then you double check charges. So, the nice thing about hydroxide, the charge is always what? -1. So, -1, don't worry about it. But then we look at the charge of lithium, +1. So, we love it when charges cancel, so we don't do anything to it. LiOH. Good. How are we feeling on bases? Easy peasy? Alright, we're going to spend more time on naming acids.
Are those the like I is us?
Yes. I ate something icky, Sprite is delicious, all of that fun stuff. Alright, let's see this.
I still think I should get points back for the last quiz. Like 5 points back.
I literally said no.
I still think I should though.
Okay.
I still think
You can believe that all you want. Alright, with acids. So we're going to start with name. And we're going to change it to formula. Who is that? Krishiv. Oh, you got a pass this time. Thank you. Alright. Alright, so the first question to ask yourself, whenever you have the name and you have to convert it to the formula, the first question to ask yourself is that, okay, is there hydro in front in the name or no hydro? If there's hydro in front, the formula comes from the periodic table. So I'm going to say P table. And then if there's no hydro, it comes from where? The back of what? I'm going to say the polyatomics, so like your special list. Yeah, where is he? Actually? Did you not feel good about the test yesterday? Huh? Well, let him know that this will be on YouTube, so he gets to watch it. So.
This is going on YouTube?
Yes.
Dang, you lied.
Yeah, everyone should know I
So if I give you the name, hydroiodic acid. So you know that since it starts with hydro, it comes from the periodic table. Again, acids always start with what?
They always start with some H.
With an H. And then iodic. What element is iodic? I. That's it. And then you check charges. H has a +1 charge. I has a -1 charge.
So you leave it.
So you leave it. So it's just hi. Alright, if I give you, let's say, hydrofluoric acid. Hold up. What is hydrofluoric acid? H. HF. And that's it, because +1 -1. Alright, any questions on periodic table hydro naming? You good? Alrighty. The polyatomics. This is where it's a little tricky. So there's no hydro, so let's say the name you get is nitric acid. So you have to, the first thing you look at is the ending here. Ic comes from 8. So instead of nitric, what's nitrates? So you put HNO3. Double check charges. H is +1. NO3 is what? -1. So they cancel out. Huh? I ate something icky. Yeah. I'll actually write it down, like, over here. Alright. Another example where charges don't cancel out. Carbonic acid. So again, carbonic. Instead of carbonic, carbonates. What's the formula for carbonates?
CO3.
CO3. And it has a charge of -2, and that 2 goes down here. Now, if you leave it as HCO3, that is wrong. Okay? Huh? I mean, each name is worth 0.25. I mean, I guess. You need every point possible, right? Alright, let's do the other way around. Formula to name. This is where I see the most mistakes, because you're tempted to just say hydro throughout, even with the polyatomics. We all love hydro. Alright, so again, the first thing to ask yourself is the formula from the periodic table or from the polyatomics? So if it's from the periodic table, you do write hydro in front. And if it's from the polyatomics from your special list, you do not put hydro. You go straight to the actual name of the compound. And the hydro one is actually the easiest one, because all you have to do is that, so hydro, what's the ending always? So always ends with, I heard it, always ends with ic. So for example, HCl, Cl is from the periodic table, so hydrochloric acid. And you have to add the acid at the end. And by the way, I've been asked this before. What if I misspell it a little? Do I get it wrong? As long as you don't completely butcher it. If I understand what you're saying, you'll get it right. As long as, like, you have HCl and you put hydrobromic acid, that's a completely different, like, compound. So, you'll definitely get that wrong. But let's say if you, like, miss the H or something, I know what you're saying. So. Alrighty, the polyatomics. The ending is either ic or what? Us. Well, ic is with 8 and ite is with us. I'm trying to. So with ic, it ends with 8. All the polyatomics that ends with 8, like nitrate, phosphate, sulfate. And us ends with what? Ite. So I'm going to write the little phrase here. I ate something icky. And then Sprite is delicious. Alright, let's say I give you HClO3. Now that ClO3 comes from the polyatomics. What is the name of ClO3? It's what? Huh?
I guess chloride?
Chlorate, yeah. So chlorate turns into what?
8 turns into 8.
Chloric acid. Excellent. And then let's say I have HNO2. What is NO2? What's NO2? The name. Nitrate. NO2 is nitrites. So nitrite turns into what? Nitrous acid. Huh? Yes. How are we feeling?
Yeah, makes sense.
Alrighty. I'm going to flip over to the back. Alright, neutralization reactions. So again, when you neutralize something, so when you neutralize an acid and a base, so acid plus base produces what plus what? What's the first product always? Water. You said it loud and proud. And salt. So what you'll be expected to write on your quiz tomorrow, Quiz Monday, is that you'll be given the first half of the reaction, you'll be given the acid and the base, and then you'll have to write down the rest. So everyone should know water, okay? I should at least see water. If you get the salt wrong, you'll at least get partial credit for getting the water right. But if you don't even put water, I don't know what to tell you. So let's say I have HNO3 plus okay. So you'll literally just be given this arrow and then it's blank. Okay? What's the first thing you always write? Water. Write H2O. Do not write water, by the way. What do you mean what? Plus. Now whatever is left is your salt. So H2O came from HOH, right? Now what's left is Ca and NO3. NO3 is part of the spell, so CaNO3. What's the last thing you gotta do? Balance charges. What's the charge for Ca?
That would be +2.
+2. So the 2 goes down here. And NO3 -1. And there you go. Good job.
It's catching up.
Huh? Alright, HBr plus aluminum hydroxide. First product is always what?
H2O.
H2O. Good. And then what's left is Al and Br. What are the charges?
Aluminum is +3.
Uh-huh.
Br is -1.
So the 3 goes where?
Next to Br.
Uh-huh. Oh, okay. Oh, it's not for you. Okay, how are we feeling on neutralization?
Yes.
Wait, will it always end like the base always have OH?
Yes. Yeah.
Because that's what bases are.
Yeah. We're catching up. Alrighty, last but not least, pH calculations. So here are the formulas, and you will be given these formulas, so do not worry about memorizing them. It's all about knowing how to use them. So do not ask me tomorrow, Ms. Haji, which equation do I use? I'll be like, figure it out, or I'll give you the wrong formula to use. So you don't have to write these formulas down, but I mean you can if you want to. But I'm just gonna put this on here so that way when we work on these problems. Can someone answer that?
No, we're not gonna change.
No, just Eli. You will not get the formulas.
I didn't say a word.
Negative, yes, negative pH. Thank you. See, you know your formulas. Charlton knows his formulas. He corrected me. Also, another thing to remember is that pH less than 7, is that considered an acid or a base? Acid. You'll be asked whenever you're solving for pH, and then it'll ask, is this an acid or a base? So based on your answer. So in pH more than 7 or greater than 7, it's considered a base. Grab. Let's do this one. For example, calculate the pH of a. By the way, hint, hint, wink, wink, nudge, nudge. Calculate the pH of a solution with the hydrogen concentration of 6.35 times 10 to the power negative 7 molar. And is it acidic or basic? So this is pretty straightforward. It's a one-step type of solving. So we have my H concentration equals 6.35 times 10 to the power negative 7. And then according to my formulas up here, I can find pH by just doing negative log of that. So pH equals negative log of my concentration, so negative log of 6.35 times 10 to the power negative 7. I'll get that for me. All done? Nice. 6.20? Good. That's what I got. 6.20. And remember, nice thing about pH, there are no units. Y'all forget units anyway, so this should be good. Now, is this an acid or base? Acid.
Is it just a chemistry thing where you'll get it wrong on like pointless zeros? Like that zero doesn't add anything.
Well, pH always has to be in 2 decimal places.
The significant digits.
Yeah.
So I feel like it's just a chemistry thing. Tell me you're not figuring it out.
We don't learn significant digits.
Yeah, this year's the first year of not teaching y'all sig figs. You learn about sig figs? Yeah. That's a pain. I hate teaching it. This year when they told us you don't have to teach sig figs, I'm like, yes.
What are those?
All right. Next example. Huh? Again, hint, hint, wink, wink, nudge, nudge. Calculate the OH concentration of a solution with pH of 8.5. Is it acidic or basic? Now, you can already answer that second part because you already are given the pH. So, it is basic because it's more than 7. Okay, now, we know that pH equals 8.5. And I'm trying to find OH. What is the formula for OH? So OH equals what? According to my formulas. 10 to the power negative POH. But I have pH.
14 minus pH.
I can find POH by subtracting from 14. So I need to find POH first. So POH equals 14 minus pH. So 14 minus 8.5, which equals 5.5. And now you can plug this in to find your OH concentration.
Wait, how do you know if it's acidic or basic again?
Because the pH is greater than 7, it is basic. The pH determines acid or base.
So if the pH was 6.9, it'd be acidic.
Mm-hmm. So 10 to the negative POH. So 10 to the negative 5.5 equals, you should get, I trust that you know how to use a calculator, 3.16 times 10 to the power negative 6 molar. Now for concentration, you have to have units. How we feeling? Let's do one more, and then we'll call it a day. Last hint, hint, wink, wink, nudge, nudge of the year. Unless, I don't know. Should I do reviews like this for the final exam?
That's a lot.
It is a lot. I don't know.
How many questions did you make the final?
I don't, no, it's been tweaked like over the years, so no, I have not. I know what's in it. Not yet though, I haven't really looked at it yet, but, I know it's, was your final last semester 40 multiple choice?
No, but it's still open.
It's about 40.
It's still open on
Huh?
online. You can still access it. Look at all the classes.
Oh, I mean, it's not going to be the same questions, so.
I can show the kids for next year.
Huh?
I can send it to them.
Good to know. We'll change it. Last but not least. Again, hint, hint, wink, wink, nudge, nudge. Calculate the pH. This is another two-stepper. pH of a solution with an OH concentration of 7.37 times 10 to the power negative 7 molar. That's not very nice. Alright, so since I'm given the OH correlates with POH. So I'm going to solve for that first. So POH equals negative log of OH, so negative log of that number. So that should be 6.13. Alright, and then how do we find pH from that? Subtract from 14. So you should get 7.87 as your pH. Final answer. Now if you stop here at 6.13, you'll get partial because you're getting there, but you're not done. Okay? But that's it.